So welcome to this short but hopefully sweet presentation of creating value through visualization. I worked quite a bit with Gaussian splatting in the past, and this will be a mix of some old tests I've done. You'll see that the quality is not, I mean, there's a new model every week. But now we're really seeing that this could be ready for production just around the corner. So that's really exciting. Oh. All right, so a little bit about me. I've been 17 years in the oil industry, 2 years in Capgemini. I work in this lovely building in Kristiansand, Norway. And I love everything 3D. That's what I do. And it's a good job to have. This is my Svein 2.0. It's a better version. He dresses a bit nicer and his hair is always mint. We're going to talk about digital twins. What do you need to create a digital twin, and what is not a digital twin in my head? And hopefully you guys will find it fascinating. So the definition of a digital twin is a dynamic virtual copy of a physical asset, process, system, or environment. I tend to skip the last part. I like the physical assets. And to create a digital twin, you obviously need some data. Without data, it's just a visualization of a 3D model. And you need some assets and you need environments. And all these parts tend to increase cost quite a lot. And that's why I think most people stop at the data and just create some dashboards and be done with it. So we need to think ahead on how we can enhance today's digital twins and how to make better ones in the future. And of course, the one step that you can't skip is collecting the data. But that had also, it's so much easier now than just a few years ago. Much thanks to the cloud providers, the big ones, Microsoft Azure, AWS from Amazon, and Google Cloud. They have built-in tools that get you going in no time. So imagine you have a factory like this, you have sensors on all the equipment, and you have some dashboards showing the data, but you want a better look, something like this, where it's easier to zoom in to wherever you have some alarms and start troubleshooting when you have a system failure or something is about to go bad. So what you need then is some sort of visual representation of your asset. And preferably you have a sensor and you can actually display the sensor data on top of it. That being in AR, VR, desktop, you name it. So let's talk about how to achieve that. Here's a quite silly demo I built today. It's connected to a dummy API, giving random values every time you refresh it. And it's me hovering in the background there as a Gaussian, inspecting the machine. And I use these images as well, just to illustrate that it looks kind of ridiculous, but it illustrates how to create something more with a user manual that's so boring to look at and difficult to find the correct information. So just by having a Gaussian splat off the machine and pasting all the information on it, you already enhance the value of the system. And on the left side here, you can see that in my mind, there's two approaches, and they both lead to a user web browser. And on the left side, you have Unreal Engine streaming from a cloud computer to your web browser. That's of course added price, but I will talk more about the things you gain at the end of this talk. And you need to be connected to some sort of API that gives you the data when requested. And the approach on the right is using our favorite mix of editors. Take your pick. They all do Gaussian splatting quite well. And for this demo here, I use Spline just because I was in a rush today and didn't want to start coding something good from scratch. So that's rendered in the client browser. The danger with that is that you can, of course, steal the model. So if it's some intellectual property involved, that might not be the approach you're going for. And now it's become so lightweight, I can hardly believe it. This file here is 2.4 megabytes. And I didn't do any trickery. I just used available tools. And I mean, it's not perfect. It was created over a half a year ago. But for a web page, for a product viewer, it's more than good enough. And then you want to step it up because you need an environment as well. If you're going to have true insight into your facility, you need to be able to see where the machine is located and what it's connected to, because maybe the problem is before the machine or after. And in order to do that, we need to step it up and get some Gaussian environment into the digital twin. You can, of course, model all the walls like we did in before times, but this creates such a extremely better result when using a Gaussian splat. And it also enables you to create training on escape routes and such, because it all feels so real when you're in that environment. And here you see the preferred way I've highlighted on with green, because now we're getting quite a big environment, and I would definitely pass it through Unreal Engine no matter what, because Unreal Engine takes CAD files and easily reduces it and imports it with the Datasmith plugin. And after that, if you still want it in the browser, you can export it as a GLTF file for later use in your favorite editor. Yeah, so that's mixing environment and the asset. And of course, you could have the asset as a splat and the environment as a CAD. It doesn't matter. You can mix it up. But I will show you the advantages of having the machine in as a CAD file later. And then we have the new possibilities with georeferenced twins. It's a lot of new words I've come up with here, but I found it on Google, so it must be legit. Cesium just released the moon, so you can even place your digital twin on the moon at a certain coordinate. And I've used this quite a lot, and I just need to take my hat off for Cesium. It's such a great product. You can use it in JavaScript in your browser, or you can use it in Unreal Engine. And here you see the different examples of the terrains you can get using Cesium right out of the box. And this is something I built for a conference. It's yeah, soon to be floating wind field in Norway. And we had actually a 3D printed model of this wind turbine. So it moved together with the 3D. And it's just a simple demo demonstrating how you can get some information on the parts just by looking at it. And for me, if some data was missing here, I would go out and scan it and bring it in and mix it up with the CAD files. And now you can see the extra possibilities if you keep the asset itself as a CAD. You step into the realm of virtual training and maintenance instructions and so on. But the good thing here, all you need is the GPS coordinates and you're good to go. You have the entire world in Unreal in every project you start with Cesium. And that brings us to cloud streaming. The reason why I work with pixel streaming in Unreal Engine is that our clients, most of the time, need to protect their IP. So we can't just expose their 3D models directly in the web browser. And you also need to be able to connect people across continents. And the good way of doing that is to keep everything in the same network in the cloud. And also, this kind of disconnects you from the limitations of the client computer. That's why I say it's the Apple approach. You know what you're getting, you know what you're developing against, and you can optimize your solution to fit the hardware that you know you are going to use. And it's quite excellent. I normally have around 100 milliseconds going from Norway to Frankfurt or Ireland. And the response is just, it's playable. If you were to play a game, it would be playable. Yeah, and you pay as you go. The more you use, the more you spend. And this is an example of pixel streaming. And just imagine this room here being filled with Gaussian splat as the environment instead of this apartment scene. And that's what I'm trying to get at. We can stop spending weeks and weeks and weeks on preparing fancy environments. We can just scan them and concentrate on the things that we actually want to display inside that environment. And this is streamed directly to a web browser with Svein client cloud is running in the same cloud, and the host is also in the cloud. And this can also be mixed with a client connecting with VR glasses, and then you just send the server information back and forth. So you're rendering locally on VR or on desktop, and you can collaborate together. And that brings us to augmented reality, my favorite. It's such a low-hanging fruit because we're all walking around with this powerful machine the size of a fist in our everyday, and it's just an untapped piece of machinery. So what I'm trying to build these days is connecting to APIs and utilizing the already existing data that we use in digital twins to create something more. And it's difficult to explain, so I will just show a video from somebody that made something for BIM, for the building market. And you can see here they need to create a QR code in the 3D. Then you print it out. And you have to get it into the correct place in the building. And when you scan it with your tablet or iPad or whatever, it will align the scene that you already created. And because of the compute power of the tablet, you you hide everything that's not data. So my concept is to just show the data on data points. Here you overlay the entire BIM, the structure. You can see the beams, you can see everything. Yeah. Oh, sorry. This is also something I just had to do a test with today. This is the 2.4 megabyte model in our office. And this is what I'm talking about. If I could spawn a machine and troubleshoot together with a colleague over the phone, over a Teams meeting, and actually see all the values of all the data placed on the machine, that would have helped me quite a bit back in the days as a service engineer. So I made this cost-benefit chart to explain a bit more of the different versions. On the left here, you see the virtual twin. You got your data, you have a 3D asset, and you have a 3D environment. That's the full-blown, everything is mesh, no Gaussian splat. And you tick all the boxes, but you also have the most amount of preparation work needed. So it's a very expensive model to go with. On the hybrid twin that I called it, you replace the environment with a Gaussian splat, and you'll probably save quite a lot of money doing so. But keeping the 3D assets, you will be able to create interactive sales configurators. You will be able to render realistic animations with movement on the machine. So in my mind, that's the best mix using Gaussian splat to enhance digital twins, is to replace the environment. On the other hand, if it's a static model, it doesn't really matter. Then you will probably have just for the digital twin, a better product, just scanning the whole thing, scanning the assets, scanning the environment, putting it all together, chopping off the roof, and you have yourself a very functional digital twin. You can still use it for escape route training. You can use it for introducing new personnel to the facilities, and also for troubleshooting. And even maybe most importantly, the augmented live data, the AR viewer, will still be possible to do with Gaussian splat on both assets and the environment. And I just need to mention the not a twin at the far right, because I've met so many people telling me that, yeah, we have a digital twin of the entire system, and what they really have is data and 2D dashboards. And for some processes, I must admit, it's enough. But for most, if it's a physical asset, it's not. And that was me. If you have any questions, are we taking them now, or are we doing it later?
I think we can take them right now. But I'll just say thanks so much for the presentation, and I really appreciate when you kicked it off talking about, what is a digital twin and what isn't a digital twin, is just a visualization, because I've often been asked to articulate the difference between a visualization and digital twin. I appreciate you expressing it so succinctly. And I was really intrigued by the by the mix of 3D Gaussian environments with 3D assets, maybe from CAD files. But I was a little confused. So in one of in the beginning, when you showed that caterpillar digger, you appeared to click on one of the hatches and it either went transparent or opened. Was that a Gaussian or a CAD, or was it
No, that was just a picture.
Just a picture in there?
Yeah. Okay. So that's just taking the documentation that you already have and just enhancing it.
Okay.
Because most people won't. Well, eventually you will, of course, try to open every hatch and do a Gaussian splat inside it. That's the dream.
Yeah.
I didn't have time to do it, and I bet our clients don't have time to do that on every equipment.
Yeah.
But I've done like 360 tours of machines before, and we have done the 360 everywhere you need to go. And when you get to a cabinet, it's most of the time it's enough just with a static picture of what's inside.
Yeah.
And maybe with some markers on what's what.
Okay, that's great. And again, like I really appreciate like the approach seems so logical and makes so much sense, you know, using the Gaussian to do sort of the heavy lift on and the time consuming environments, and then using the maybe the assets you already the CAD assets you already have, which have the interactivity baked in. It's really smart. So we have a first question from Ruben. I don't know whether this is your area, Svein, but he's asking, has anyone used hybrid twins in film VFX?
Ooh. I do not know. Maybe we have somebody else here that might be a specialist in VFX.
Yeah, because your background is oil and gas, right? So it's
Yeah,
a bit
it's always
outside.
been big, heavy machinery and how to visualize it.
Okay, there's a bunch more questions dropping in, but let me ask one. So again, the Caterpillar digger, you said the model was about 2.5 megabytes. Could you talk to us about what software you used to create and to compress it? Because that does seem pretty light for a model like that.
Yeah, it was quite fascinating. That was actually Super Splat. That because it was a long time ago and that was the only thing I had available. So I used the compress method in Supersplat, and I got that result.
Okay.
And I actually forgot about it. I found it today because I usually use a model that's 15, 30 megabytes.
Yeah.
But I just tried to load it in and I couldn't see the difference.
Yeah.
So
Yeah.
quite surprising.
Okay. Amazing. So again, like some more questions about the Caterpillar. So what technology library have you used for showing the 3DGS Caterpillar in the office in AR mode?
That was Play Canvas
Okay.
Viewer. It has a great augmented reality functionality there. So if you just made a splat and you want to see it in AR, just go to Play Canvas / Viewer or something like that, and load it in from your phone, and it's all client side rendered, so you never upload your model to Play Canvas. So it's
Okay.
a great way to showcase your work.
Okay. And let's see. Okay, so some questions about cloud streaming. Um, could you go into a little bit more detail why cloud, or I guess it was pixel streaming, I believe.
Yeah.
Why pixel streaming is more secure than other methods? And then I guess the other question would be, could someone just rotate the images you're streaming and create their own 3D model out of that?
Yeah, of course, that's the only thing you can never protect against. But come on, it's but the reason why it's more secure is because you are never exposing any 3D models for rendering on your GPU. Because if you do that, I could do a whole presentation about it. I have 10 slides lined up. You can scrape anything off a GPU, so you must never let your 3D model escape your security bound and get to the client's GPU, because then it's pretty much gone. So when you do pixel streaming, you stream a video from the buffer on the NVIDIA card
Yeah.
on the computer in the cloud. And since it never even touches the CPU on the cloud computer, it just streams right out as a video, and it captures your keyboard and mouse input and sends it back to the server, and you get a new picture.
Mhm. Okay, that makes, let me just see. Again, okay. I think these are going to be like customer leads. So here's a person who works, this is Vincent, who works in a museum. He leads a 3D program. He says, have you seen examples of processing turntable photogrammetry data sets into G-splats? We have a huge collection of legacy data.
Isn't that particularly bad at producing Gaussian splats, since you never move your camera? You don't have any depth.
I mean, I've had success doing it. I mean,
Have
it
you?
wasn't easy, but I mean, I was able to turn, you know, if you know the void method of doing photogrammetry using cross polarization and a void, that you can turn into a Gaussian splat pretty easily if you process with reality capture or with Metashape. You can do that.
Okay. Hmm.
Let's see.
Not much help there.
Okay. Oh, right. Well, things this because our audience is really broad, right? So
Yeah.
you'll see like what I've found is like you can't anticipate all the different applications people are finding for Gaussian splats. Here's a question. Do you animate only working machines or also disaster scenarios?
Oh, one of the reasons why we want to build a digital twin at the details level that we want to is so we can do stuff like that later.
Mhm.
So definitely anything you can think of that you want to train on, that's a big priority when I try to visualize how at what level we need to set yeah, the digital twin.
Okay, cool. And then this is a question about AWS. Do you think, and this is from Samsi, yeah, Sam Smee. Do you think an AWS pipeline can also help to save Gaussian splat assets and 3D assets on the cloud and show them on the web?
Oh yeah, sure. That's that's the way to do it. You have a server, you have a API where you can post your videos, and you that I mean that's how Luma Labs and all those different sites work. You post your video and you get the Gaussian splat back. You can have that privately, of course, if that was the question.
Yeah, I think so. I think
Yeah.
so. Okay, so I think we've hit. Oh wait, here we go. One last question, and I'll let you go. Are you streaming pixels in stereo?
Oh, I've done it locally. I have that on my bucket list to try because yeah, and you can do pixel streaming, but you can also do NVIDIA's own XR, and I signed up for that, but I haven't gotten around to try it yet
Okay.
because 100 milliseconds is not a lot if you're on a desktop, but if you're in VR, it's quite a lot.
Yeah. Okay. Well,
And you need to render 2 images, and you need to be above 75 FPS. So you need to. It's gonna cost you.
yeah. So it sounds like latency would be the big
Yeah,
obstacle. Yeah. Okay. Cool. Okay. Thank you, Svein. The really interesting presentation, and appreciate you coming on. Would it be all right if people reach out to you on LinkedIn if they have follow-up questions?
absolutely. Just write to me.
Okay. Awesome.
Thanks,
Thank you.
Mike.
Thanks so much.